Alright, welcome to our last video of our 5th unit of AP Chem. This one's called Non-Thermodynamically Favored Reactions. Here you go. So, many reactions are not thermodynamically favored. They're not likely to happen. But with an appropriate power supply can be made to react. For example, batteries. Once their energy is run out, they're not thermodynamically favored. They're not really useful for powering much. However, if we run electricity through them, through a process of electrolysis or however we do that, we are able to reverse this favorability. We can then use these a little bit more, if you will. In the process of electrolysis, we use electricity to decompose substances. This makes reactions occur that normally wouldn't. Basically, we just throw electricity at it and it gives it power. Commonly use of it that I've honestly never heard of, to be honest. I don't know why I said honest 3 times, but whatever. Is you decompose molten sodium chloride into its individual elements. I've never seen molten sodium chloride, but apparently they do that. Keep this in mind. Another option is what's called the photoionization of an atom. This is another process in which energy, this time however in the form of light, typically we call it a photon, hence the photo part of it, which usually jumpstart a reaction that really doesn't normally happen. Photoionization definitely is when a photon is used to ionize atoms, as we'll see in just a second. So it occurs when a molecule in the upper atmospheres absorbs enough solar radiation, commonly called sunlight, and that absorbed energy causes an electron to be ejected from the actual molecule, like it leaves the area. That then becomes a positively charged ion, and thus we use photoenergy to ionize an atom. For that to occur, therefore, a molecule must absorb a photon, and the photon must have enough energy to remove an electron, which should be kind of obvious. It has to absorb light, and it has to absorb enough light. Now, that process you've probably not heard of a whole lot. I hadn't when I started looking into it. However, the next process you've probably heard of just a little bit. A process called photosynthesis. Now, photosynthesis is basically a process where you're making something, hence the synthesis. Commonly, we're making glucose. But you need energy, hence the photo. Now, this is a reaction that you probably had to memorize in 7th grade. To be honest, I think I memorized it, but I couldn't tell you at the top of my brain. That's an odd reaction. You will notice, however, this is a reverse combustion reaction. So you've got a hydrocarbon and oxygen, but they're being produced from carbon dioxide and water. However, biggest thing you need to care about is our delta G. That is extremely stinking positive. Now, you've seen plus 2.8 or 30 or whatever, maybe even 100 kilojoules per mole. Not almost 3,000 kilojoules. That means you need a ton of energy just to make sugar and oxygen in plants. So, let me give you an exact idea of how much energy. So, in order to produce 1 mole of glucose, we need approximately 48 moles of photons of light. At least with wavelengths ranging from 400 to 700. Basically, the common light that a plant will have, you need 48 moles. Now, I can make that sound huge, but I really don't know what 48 moles of photons light looks like. So I looked it up. That is basically a little bit less than about a full day's worth of energy in San Diego on a typical San Diego sunny day in the middle of summer. Meaning you need an entire full day's worth of energy just to make that reaction happen once. Now, that is definitely something I would say is not thermodynamically favored. However, the goal of this video, besides just giving you some cool examples, is to show you that just because something's not thermodynamically favored does not mean it won't happen. It means typically we need to throw energy at it. That could eventually get it to occur. Just keep that in mind. And I don't really know why this sentence is on here. I was looking at this earlier. But nonetheless, with sufficient light, this reaction can occur despite it not being thermodynamically favored. I'll probably take this out next year. I just said this like 5 times. With that, though, that finishes Unit 5. So, congratulations. You are now a introductory thermochemist. Yay. Thanks for watching.